All right, good afternoon, students. This is Mr. Gucci here. I just want to go through and sort of clarify some of the laws of exponents pages from our little laws of exponents booklet here. What we'll do is go through those, not the examples, not all of them. Just I want to sort of give more clarification for why rules are what they are. So here we go, one page at a time. Here's what we're going to do. It's going to open it up. The first rule: x times a, x to the a times x to the b is x to the a plus b. Okay. X to the a times x to the b is x to the a plus b. Put a 1 there because that's page 1. Now let me move this so I have some room. Let's try to figure out why this is, because that by itself is very abstract. Now if this makes sense for you, then you can pretty much skip this tutorial. But clearly if you're watching this, it's maybe because it didn't make sense. So let's try and use numbers. Okay? Because variables, not everyone's favorite thing. So let's say we had 5 to the 2 times 5 to the 3. So what's confusing here is you have multiplication and you think, okay, it's 25. No, that's not what we do. You say, okay, well, it's 2 times 3. No, that's not what we're doing. What the answer is, according to this rule, is it's base of 5 and 2 plus 3. Well, that's the same as 5 to the 5. Now, why is that? That's the important question. Okay, because if you forget this rule that it's addition, then you're going to be out of luck on the quiz. You're going to be really in trouble. So let's rewrite this. 5 to the 2 by definition is 5 times 5. 5 to the third by definition is 5 times 5 times 5. So what do you have? You have 5 times itself 5 times, which is the same as 5 to the 5. Whoops, what did I write 2? 5 to the 5. And those are now the same. 5 to the 5 power. Okay, so either way, the shortcut is addition. The long cut is show all the work. Okay, so that explains page 1. And that's what I'm going to do in this video, is just go through each one of these one at a time. All right, page 2. X to the a over x to the b means you subtract the exponents. Now again, why do we subtract the exponents? The rule's useless if you don't understand why it is. Okay, so this is just a shortcut. So let's see why it is. So again, you use the same numbers. Let's use 5 to the 4th this time and 5 to the 2 this time. Well, according to this rule, same base is 5. According to the rule, it should be 4 minus 2, which is 5 to the 2. But again, why is that? Because without understanding why, this math is going to be useless for you. So the reason why it is if we rewrite this as 5 times 5 times 5 times 5. The bottom is 5 times 5. So what's happening here? You have 5 to the 4th is 4 5s on the top. 5 times itself 4 times. And on the bottom, 5 to the second power, 5 and 5. So what happens here is these reduce each other. 5 divided by 5 is 1. 5 divided by 5 is 1. And what's left? 5 times 5, or 5 squared, which again is what we had to start with. Okay? So that's what we're going to try and do, is try and explain why it is. And if you get stuck on the quiz, if you're like, oh, I forget, do I subtract them, or what do I do with these? Write it out the long way and you should be able to figure it out. Okay. Page 3. Let's move this over here. In fact, let's get some new paper. Okay. Page 3 in our Exponents book is the rule of a power of a power. You have x to the a raised to the b. That's x to the ab. Okay. So, again, that barely makes any sense because there's no numbers in there. Let's get it back to numbers. 5 to the 2 to the third. So what it's telling us here is that'd be 5 to the 2 times 3, because AB is A times B, or 5 to the 6. So the question is here, why are we multiplying this time? Okay, well, let's try and figure this out. Let's rewrite the whole darn thing. 5 to the 2 to the third power. Let's cover this up. Anything to the third power. My finger to the third power means write it 3 times. Okay, so if it's x, you write it 3 times. Whatever it is inside, write it 3 times. So let's write it 3 times. Now, what was inside? 5 squared. Okay, so all we did is we said 5 squared. Whatever's inside, write it 3 times. We did that. But what is 5 squared? Well, 5 squared is really 5 times 5. 5 squared is 5 times 5. 5 squared is 5 times 5. And how many 5s do you have? You have 6 of them. So you have 5 to the 6th. All right, and that's that. That's the reason why what we're doing is multiplying. Because what's really happening is there's a total of 5 written 6 times, so 5 times 5 times 5 times 5. So 5 to the 6th. All right, moving on. Rule number 4. This one's a little bit maybe self-explanatory. If you have a product inside, they both get the exponent applied to them. That's all it's saying. All right. So you have a product and a power. Okay, I'm not too big on making you memorize the names of them, but in case you do have a teacher who asks for that next year, you have a product. Product means multiplication, and power is the same as exponent. So, but again, let's do this with a numbers thing. Let's say it's 5 times 3 to the second. What this is saying is you can do that as 5 to the second and 3 to the second. Which, if you wanted to, we'd probably say, okay, that's 25, and that's 9. All right, so that's 225. Okay, of course, there's other ways to get this. All righty, let's do it this way. Well, if we have 5 to the 3 times 2, well, that by itself says write it down twice. Second power means multiply it twice. So what this would be 15 times 15, which again is 225. So again, the nice thing in math is if you know how to do it multiple ways, you should be able to verify your answers multiple ways. You should always know you're correct because you've checked it. Okay, that's a good strategy. You should pretty much always be checking. Okay, next, let's wrap this up. Next, very similar. If you have a fraction with a power, the power goes to both of them, top and bottom. Okay, again, whoops, didn't realize I was running way over here. Okay, here we go. X to the a over y equals x to the a over y to the a. So again, why this makes sense, if we had 2/3 to the 4th, it's saying that's the same as 2 to the 4th, 3 to the 4th. Again, the question is why? So if we rewrite this, anything to the 4th power means write that thing 4 times. So that's 2/3, 2/3, 2/3, 2/3. 2 times 2 times 2 times 2, 2 to the 4th. 3 times 3 times 3 times 3, 3 to the 4th. And again, you get the same answer. These should always be in agreement. If you do it by another method, you better get the same thing. That's the whole thing about math. Okay, getting to one of our trickier ones. Our last two are a little bit tricky, so let's try and go through it. Number 6 is saying, page 6 has the negative exponent rule. Okay. X to the negative a is 1 over x to the a. Now, how do we get from here to here? Well, part of what it is, if you did 1 to the a, it would still be a. Some people are like, well, why isn't there an a on there? Well, you could put it there, but 1's always going to be 1. 1 times 1 times 1 times 1 times 1 will always be 1. Okay, so what we got then? Let's use a number to sort of try and figure this out then. The number we're going to use is, let's say, 2 to the negative 3. So according to this, that's going to be 1 over 2 to the 3rd, which equals 1 over 2 to the 3. Technically, like I said, it's 1 to the 3rd, 2 to the 3rd, or that's 1 over 2 to the 3rd, which you could also rewrite as 1 to the 8th. The question I'm trying to get to here is, why is it that a negative makes it upside down? Why does the negative make a reciprocal? Okay, so the y here. So let's go back to, let's try and use a slightly different example. I'm going to start this way. Let's say we had 2 to the 2 and 2 to the 4. Well, based on our previous rules, the rule says this should be a subtraction problem. Okay, 2 to the 2 and 2 to the 4. Because we're dividing, you do subtraction here, now 2 minus 4 is going to be a negative 2. So if you tried that, you'd be like, well, how does that even make sense? What should a negative 2 exponent mean? Okay, so the question is now, what? Okay, so let's try this our other way. 2 to the 2 is 2 times 2. 2 to the 4 is 2 times 2 times 2 times 2. Now what's going on here, 2 divided by 2 is 1. 2 divided by 2 is 1. So we have 1 on top and 2 on the bottom. Okay, because 2 divided by 2 is a 1. That's where we get the 1 on top. What's left over are 2 2's on the bottom, which is 1 over 2 to the 2. So we did it 2 different methods, and as we've been saying, both methods have to be in agreement. Therefore, the answers have to be that the only thing that makes sense is that a negative exponent becomes a reciprocal. Negative exponent becomes a reciprocal. Okay. Final things here. Last one. The zero rule. Now, for some people, this is the easiest one to remember. Let's move this down. Okay. X to 0 equals 1. Okay. That other part of that rule just said that you can't put x as 0. 0 to the 0 can't be done. So, but for the most part, you're never going to have to worry about that. Let's focus on the fact that why is it 0? Why isn't it anything else? Okay. Well, in order to explain that, I want to go through a number we already know, something similar to what we just did. We had 5 to the 2 and 5 to the 2. According to our rules of exponents from the previous page, division becomes subtraction. You're dividing two things with the same base, so you get 2 minus 2. But we know that would be 5 to the 0. So the question still is, well, 5 to the 0, what is that? Okay. And that's what would have pondered or would have bewildered ancient man. There's ancient man right there. Okay. So let's, again, like we did before, let's do it another method. 5 to the 2 is 5 times 5. 5 to the 2 is 5 times 5. But we know 5 times 5, that's just 25. 5 times 5 is 25. Well, fractions mean division. So 25 divided by 25 is just 1. So if we did it this way and it equals 1, and we did it this way it equals 5 to 0, the only thing that's possible is 5 to the 0 must be the same as 1. And that explains why anything to the 0 is 1. Any number to the 0 other than 0 itself. But if you have x to the 0, it's 1. If you have 5 to the 0, it's 1. If you have 10 to the 0, it's 1. A million to the 0 is 1. All right? And thank you for watching. And that is the end.